Be terrible. Okay, so again, homework will be due on Thursday, and we'll start reviewing Thursday for the semester test. You'll have a physical copy in your hand of the practice guide that will turn in. Okay, so examples of derivatives. So one of the derivatives we talked about yesterday was e to the x. So I'm gonna make up something with chain rule in it. E to the 4x squared. So the 4x squared is in the power. So this is a chain rule problem. So I'm kind of mixing a couple of review questions. So when we take the first derivative of this monster, what do? What's the derivative of e? E. So it's just going to be the same item that you started with, right? So that didn't change. That's great, because that's e stays e. Then after it, we have to multiply by anything that's in the power. So what is the derivative of the 4x squared? 8x. And that's it. That's your answer. Now if you want to rearrange this thing and make it a little bit easier to look at, maybe you want to put the 8x out front and write it like this. That's totally fine. It doesn't matter. It's just a preference thing. Some professors like to have the 8x out front. Doesn't matter. Questions with e? Okay, you're going to have a problem today that's going to have an e and it's going to have something in the power that you have to take a derivative of. So be careful of that. That's the shortcuts for e. It's a chain rule. Okay, next one that we have. So next one, if we're going to have, you know, f of x to the, let's go with like 7 to the 4x. Really similar, right? Really similar to the last one. So on this problem, since it's a number to a power, this is an exponential. It's not just the natural number, it's an exponential. So how you take the derivative of this?
Natural log.
Yeah, it's the natural log of the base number, whatever's in that base. Okay, so it's not the full power, it's just whatever the base number is. Then you multiply it by itself. So it's kind of like the e idea. So that just stayed the same. Then we have to multiply by any derivative. If there's something weird in the power, you have to multiply by that derivative. So it's like a chain rule again. So what is the derivative of 4x? 4, and that's it. Now if you want to rearrange this mess, you can do that. Some professors like to have the 4 and the 7 to the 4x out front in front of the natural log so that it doesn't look like it's in the parenthesis with the 7. It doesn't really matter. You can leave it like this as long as you have the dots and it's very clear to see that. But again, this was a chain rule again. Its normal rule is just the natural log of the base times the itself. But since the power was complicated, you had to do a chain rule. So that was the extra piece we added in the back, or we multiplied in the back, I should say. All right, questions on exponentials?
Any questions?
Heard a yes.
No.
Okay.
I think this one, no.
Okay. So let's jump to the next one. So this was one of our new ones we had yesterday. So natural. Let's do the natural log of something. So this is one like we did yesterday. I'm gonna go 5x plus. Let's go 3x squared. This is one that we did yesterday. So if you don't remember how this works, when you do the derivative of a natural log, you are going to take the derivative, and whatever's in the parenthesis will go on the bottom of a fraction by itself. That's the first step. So you drop the natural log and you put 5x plus 3x squared on the bottom. Then we have to multiply by the derivative of the inside. So again, it was a chain rule kind of a thing. So what is the derivative of the inside?
5x or 5 times 6. 5 plus 6x.
There you go. Okay, 5 plus 6x. So again, now if you want to rearrange this thing to make it look a little bit better, like clean it up a little bit, you can multiply that parenthesis to the top. So you can write it like this. You can write it like that, and that would be the same answer.
No.
All right. Questions?
No.
Okay, we did those yesterday. So it's a chain rule. That's why I spent pretty much the whole time yesterday talking about chain rule, because of this situation. All right. The new stuff we have to talk about today. The brand new stuff. We have to talk about the trig functions today. So we have to talk about sine, cosine, and tangent. And then we have to get to some special cases where we're going to talk about the arc sine, the arc tangent. Yeah, arc is inverse. So I'll discuss that today. So. Alright. Just kind of waiting you guys out. Question?
Are you coming back tomorrow or Thursday then?
Yep. Tomorrow. I come back tomorrow.
Well, you said you didn't know for sure.
Yeah. I found out last night. They emailed me and they even called me today to confirm it. So.
Nice. Okay. See you tomorrow.
Yep. Okay. So let's continue on with our notes on trig functions here. So, all right. So I only got a couple more slides I want to cover today, and then give you some time where you can kind of go find some first derivatives. This stuff is meant to be like really straightforward and really simple. So, this is kind of going back to our basics again. It's not doing like super complicated second derivatives, you know, with quotient rule or product rule or anything like that. My last question of the day will be kind of a more complicated one, just because I'm going to kind of throw some different things at you. I'm going to pick a problem right out of the book that kind of looks like your homework problem. So I got my book sitting here, so I can pick one out that kind of looks like yours. But that's what we're going to look at today. But yeah, so we're gonna get to that. Let's jump right in. Let's do the derivatives of the normal trig functions on this slide. So these are just the quick little shortcuts, so you know it. So if my original function is the sine of x, the derivative of it, the derivative of sine is cosine. And then you take it times the derivative of the inside. So, you know, if the derivative of the x is 1, so you'd multiply by a 1 on the back. It's like a chain rule. You don't need the 1, but that's what you do. So if there's something complicated on the inside, you'd always take it times that derivative. Okay, does that make sense for sine?
Yes.
Okay, now, for cosine. For cosine. And again, we talked about these in the last unit. And I even explained like why the derivatives turn out the way that they do. We looked at the graphs of them, so that explains like why the answers turn out the way that they turn out. So the derivative of cosine ends up being, so f prime of x ends up being a negative sine of x, and then you take it times the derivative of what was in the parenthesis again. So that would be a 1. So if there's something really complicated inside the parenthesis, inside cosine, you take it times that derivative after. So that was cosine. And then the last one we covered was tangent.
Ward, can you hear me?
Yeah.
Ward! Okay, so is it just multiplied by 1? Do we even have to write it down?
No, you don't. I'm just putting it there so you remember it's like a chain rule. You don't need to put the 1 there. Good question. Good question. All right. Now, tangent. This is the one that we had 2 different options for answers for this one. So the derivative of it, the derivative of tangent, ends up being 1 over cosine squared of x. And then we multiply by whatever's in the parenthesis again. So the derivative of the item inside the parentheses is a 1, right? Again, you don't need to put that. I'm just writing it down so you remember it's a chain rule. Now, there was a secondary option on this one. There was a secondary answer for this. The second answer for tangent, instead of like 1 over cosine squared, that's the same as secant squared. Times 1. These are the same answer, because 1 over cosine, if you do the trig identities, you could substitute in secant instead of 1 over cosine, and it'd be squared because cosine was squared. They're the same answer. I almost prefer the cosine one, but if I had to find a second derivative, I'd probably have to go to the cosine problem because that's the only one I know the derivatives of. All right, questions. All right. Okay, so now here's what I want to discuss. We're going to talk about two new derivatives here. I'm going to probably explain them tomorrow when I'm back in class. We can go through kind of why they work, but I want to show you them today. So these are kind of our new properties that you need to have. Okay, and I'm gonna tell you what they are to begin with today, but I'll explain like why they turn out the way that they do tomorrow. So what we're going to talk about is my function will be the arctangent. That's arctangent, which is better known as this. That's what arctangent means. Now, if you don't remember what tangent to the little -1 is, what this stands for, it's an inverse function. So when we did tangents a long time ago, like tangent functions, and you took this tangent to the other side, and you're going to calculate what the angle is, you had to find this button on your calculator. Right, you had to find that button on your calculator. It was tangent to the -1. We called it an arctangent. That button is solely used on a calculator to find angles. My dog just knocked on the door. That's what an arctangent is. So if you don't remember, you can look at the little poster in my room off to the right, or the left side, I guess, of the room for you guys. That picture shows the inverse functions above, the trig keys. So like sine -1, cosine -1, tangent -1. Those buttons are only used to find angles. That's the sole purpose of them.
Why don't we just call it inverse tan?
Yeah, I mean, that's what it is called. They just have different names. They call them, arctan, inverse tangent. They call them tangent to the -1 key. It's all the same thing. So hold on, my dog's knocking on the door. My dog knocked on the door.
I swear he's fun. Just bark at us, Ward.
What?
Ward, can we see your dog?
Yeah.
Please.
That's one of them. Two of them came in. The big dog. Oh yeah, that one, she is 2 tons of fun. Alright, yeah, they knocked on the door and they wanted in. Alright, so, so this is arctan or inverse tangent. So we're going to be finding the derivative of this. Now I'm just going to show you what the derivative is today, and then tomorrow I'll explain in class like why did it turn out to be this weird number. So when you take the derivative of this, and I'm just going to use this one up here. This is what most textbooks have. I know your calculators and your cell phones don't have that key. They have this one. They have that key. It's the same thing. So when you take the derivative of it, the derivative of arctangent, it's 1 over 1 plus x squared. That's the derivative of arctangent. So whatever is in that x location, that is going to go on the bottom in that same x location. So whatever was printed here, right? That could be something super complicated. It could be, another trig function. It could be some polynomial. That's going to be printed right here, and you're going to put a power of 2 on it. And then obviously this is still a chain rule, so we would still take it times the derivative of the inside. So on the back, on my case, I'm still multiplying by a 1 because I have to take the derivative of the inside of that parenthesis. Okay, so let me do an example here. Something that, maybe I put something a little more complicated on the inside, so you can kind of see how that's going to work. Let me get rid of this stuff here. You don't need this. So let's say that my function had a let's put like a weird, let's put something weird in there. Let's go like tangent, and let's go like e to the 4x. So this is arctangent of e to the 4x. And again, when the book writes it, they usually put arctangent like really close together. So they'll write it like that. Sorry, I'm putting a space, you can see it. So arctan. So again, how you write this. You would, if we're taking the first derivative, right? You're going to go 1 over 1 plus whatever is in that parenthesis squared. Right? That's the derivative. Then we have to multiply by the derivative that was inside the parenthesis. So what is the derivative of e to the 4x? E to the 4x, and then that's a chain rule, so there was something complicated in that power, so the derivative of times 4. And that would be your final answer. Now if you want to clean that thing up, you could move this mess to the top. You can move that e to the 4x all the way to the top because it's going to get multiplied. It gets multiplied on the top, and I just kind of rearranged it a little bit. But again, that was like a chain rule in a chain rule. So you just keep taking the derivative of the inside until it's exhausted and it's all the way done. Does that make sense? Okay, we have one last one. This is my last one today. That was the complicated one, by the way. All right, last one today.
Pause. I have to absorb.
Isaac needs a second.
Okay.
I just need to slow. What did you say?
You sound like objects. Taking different
So he's explaining it to me real quick.
Just a few more seconds.
Okay, moving on. All right. Okay, so this is the last slide for me today. So we'll do a kind of a challenging one that I'm just going to pull out of the book on this one. All right, so the last one. So let's say my function now, and we're just going to do one more of these. We're going to do the arc sine now. Okay, arc sine. So that's the inverse sine key. It means the same thing as this on a calculator. That's what most textbooks have the arc sine written, not this sine to the -1 key, because they don't want you actually doing that mistake where you drop the -1 out front and do it that way. This is just it represents an inverse kind of a thing. What we're going to look at is how to take the derivative of this thing tomorrow. I'm just going to show you what the derivative is and then just do an example like I did in the last one. Again, arc sine means you're trying to find the angle. That's what that button's used for. That's the only sole purpose of it. It's used a lot in calc and pre-calc to find angles for like really complicated triangles and whatnot. But if you're going to take the derivative, find the slope of the line that, that for that triangle. You're trying to find the slope of that pitch that you're trying to work with. This can help you do it. So, how you do this? So the first derivative is going to be 1 over, so it's kind of mimics that whole tangent idea that we did earlier where you had that 1 over the 1 plus x squared, but this one's different. So on arc sine, it's going to be a square root, and then it's 1 minus x squared. So a little bit different. Again, we're going to explain this stuff tomorrow. I'll kind of walk through the proof of it and whatnot. We'll look at it tomorrow. We'll put it on the board. Hopefully it'll make sense why they came up with this weird thing here. All right. Now, if we do something like in this problem, so because again, this x could be something really complicated, that would still be printed here. So I'm going to do an example of this. So I'm going to pull one directly out of the book, what they have. So, So here's my final example of the day. So let's say that my function was arc sine of tangent of x. So it's the arc sine of tangent, right? So it's really kind of getting messy because now we have things inside of other things. So again, just like before, when we take the first derivative of this thing, so the first derivative, it's going to be 1 over the square root, because that's how arc sine works, right? It's 1 over that, and it's 1 minus, then whatever's in that parenthesis, squared. And then, since this thing was complicated, we'd have to multiply by whatever's inside the parenthesis and its derivative. So, what is the derivative of the inside right here? What is the derivative of tangent? We talked about that one earlier. Yeah, 1 over cosine squared. And that would be your answer. So that I consider that one to be kind of complicated because we have parts inside of other parts. So it's kind of like a chain rule. I don't need to go further. The rest of that, if I were to do the chain rule, I'd still have an x inside of a parenthesis and I'd have to multiply by 1. But that was just the rule. So, all right, homework is on Google Classroom today. You have, I think it's like 5, 6 problems, something like that, where you have to find a derivative. I'm pretty sure. And so we're going to be using those examples as kind of our topics to kind of review a little bit. It's kind of hitting every topic we've talked about. It's going to have product rule. It's going to have quotient, or I don't think it has quotient, but it has chain rule, has the natural number, it has E, it has the trig functions. And so we're going to be looking at this stuff tomorrow. This assignment's due Thursday. So we're still going to do some notes on this stuff tomorrow, and I'll give you some time in class tomorrow because I think we have like the shortened classes again tomorrow. So we'll do a couple examples of this stuff. So that way you get a chance to kind of see how this stuff works. You get to see some more examples of this homework style problems. They're meant to be quick hitters. There's a couple tricky ones in there, so be careful. But not like crazy difficult like that quotient and product rule stuff we did like a while back. So, but I think tomorrow my goal is to do a couple product rule problems where we do the products where things are being multiplied together. So we're going to look at that tomorrow. All right, but that's it. I'll see you guys tomorrow. I'll be back. Remember, semester test for us is the Tuesday after winter break. So, but I'll be back tomorrow and we'll go through stuff. And we'll start reviewing for the semester test on Thursday. We always do a 5-day review leading up to it. So. Alright. Well, have a good one, guys.
Wait, Ward, can you show your dogs one more time?
They're sleeping here.
Can't see them. It's dark. Where's the knife?
They're sleeping on the couch in my office. So. Morgan, I can hardly hear you. Is that microphone working? I don't think it is.
Do we get a note card at all? Or do we just have to remember?
You're going to have to remember. There's going to be certain things I'll have on the marker board, but there'll be no note cards or nothing. Yeah. Good question. Yeah, your microphone, I could hardly hear you in that. I don't know if it just wasn't plugged in all the way, maybe.
Yeah, I put my headphones in, and I took them out, and now I can't hear you very well.
Oh, no. Yeah, it just must have been a glitch. Might have to restart. So.
You say we're done?
Yep, we're done for the day, so I'm gonna let you guys go. So.